Okay, guys, so we did the first part for the prism when you're looking at the little reticles with measurements that are less than 1 diopter. But now I wanted to get into the real meat of what I wanted to chat about today, and that was compound prism. Let me share my screen again. And this is really could be a confusing section for a lot of folks because there's a little bit of math, but there's also a lot of thinking involved. And sometimes we don't see it that often, so it's not something that we see all the time. So when you're looking at a prism in an RX, I'm hoping that you are very, very good with, say, horizontal prism. And we talked about how if you have base in and base in, they add together. If they're out and out, they add together. If they're in the same direction in terms of to my left or to my right, meaning if it's base in the right and base out in the left, they're both sort of pointing in the right direction, so they sort of offset one another. And so there's less imbalance. So for example, if you had 2 base in the right eye and 2 base in the left, that would be a total of 4 prism diopters base in. Pretty straightforward. If we had 2 base in the right eye, but 2 out in the left, as I'm looking, they're both to my left. They don't cross, they cancel each other out. I don't see, they're not fighting against one another. So there'd arguably be no imbalance. It doesn't mean there's no effect, guys. Please watch out. If you put 2 in and 2 out respectively, there would be no imbalance, but that would really shift the image to the patient's right, and that would cause a lot of issues. But for our purposes of adding them together, there's no imbalance. For vertical, if I have 1 up and 1 down, that's the idea of splitting, they would add together. So if I had 2 up in the right, 2 down on the left, that would give me a total of 4 diopters of vertical between, there'd be 4 up in the right, or 4 down in the left, or however you want to do it, 4 up in the right and none on the left, 4 down in the left and none on the right. Or if you split the prism, 2 up in the right and 2 down in the left, arguably should have a similar cumulative effect or total effect. And if we had both down, say 1.5 down and 1.5 down, for example, there's no imbalance. And that's what we get oftentimes with, say, prism thinning. Now, it's again, not that it won't have any effect. We oftentimes have folks say, I'm walking down a hill, I feel like I'm standing on top of a ball. Other folks say, I feel like I'm in a hole and I'm walking uphill. Those are too much vertical, either up or down, respectively. You could have problems with your patient's vision, even if there's no imbalance, if there is a vertical component in both eyes that's equal. We're not getting into that right now. That's something you should have already seen. But I'm talking about when we are looking at the total imbalance or the total prismatic effect in terms of the difference between the two. So if I showed you this, this is my lensometer, and I'm not going to make any hard ones here for what we're doing. We're not going to have anything less than 1. I'm not going to ask you that half or a quarter. But for this one, it's pretty straightforward. As if I'm looking in the lensometer, and if I had my sphere and my sill lines coincide, or they matched up right where that X is, you can clearly see that's 2 prism diopters. So now my trick question is this base in or base out? And you should look at it and be able to tell me that you can't tell me unless I know which eye it is. If that cross, if that X was up, 2 up is the same in the right, same in the left. 2 down, same in the right, same in the left. But when it's looking to my right, I have to know whether I'm looking in the lensometer at a right lens or if I'm looking in the lensometer through a left lens, because it matters on how the patient is looking through this particular lens. So if we superimposed sort of a misty little ghost type frame for our purposes, you need to look at this in such a manner that pretend when you're looking at the lensometer, this part right here has a frame over it as the patient or as the pair of glasses is looking up at you. And if that's the case, as I look at this X that is to my right, well, if this center of reticle is focused over the center of their glasses or over their eye, the direction of the prism or the base of the prism would be in towards their nose. So if I'm looking at this and I have two diopters to my right, that would be base in prism from my right eye. Now, if it were the left eye, it's still, as I'm looking at it, two to my right, but as the patient's looking out of, if it's to their left in the right eye or to their left in the left eye, it's base in the right, or in this case, if we center everything here, if this lensometer, pretend again, this frame is in the lensometer looking at us, and which direction is the base? And in this case, the base to my right is the patient's base out. And again, this all should be very, very repeat. This should be review from your previous dispensing materials classes, but I need to make sure you have this down pretty solidly before we get into compound version. And the question is, what about if the doctor asked for something that looks crazy like this? Two base up, two base out. Sorry about that, I had a little glitch there. So if I had the prism and the RX, and what happens if I saw something like this? Two base up in the right eye, but in the same eye, it's two base out as well. And then the left eye, two base down in the left eye, and two base out. Well, if you separate the two up and the two down, that makes sense because they're in opposite direction in that vertical component. And base out, well, they're both opposite of one another. This would be a total of four base out and a total of four of vertical imbalance with its up in the right eye, down on the left. But this is a different animal when I'm laying it out in the lensometer, or if I'm trying to identify it, or if I'm trying to verify that the lab made it right. And this is one way you may see compound prism, because there's both a vertical component in the right eye and a horizontal component in the right eye. And in the left eye, same thing. There's a vertical and a horizontal. There's another way you can see it written. It's a little bit less common, but it's still there and it's still fair game. And you as an optician should absolutely know how to do this. What happens if the doctor asks for 3 prism diopters at 45 degrees and 3 prism diopters in 225? The first one would be the right eye, the second would be the left. Let me actually fix that in the slide. So this is a very fair example. You could have 3 prism diopters at 45 on the right, 3 diopters at 225. And here is where, oh, we weren't sharing. So I'm going to stop that for a second. I'm either going to, I apologize, guys. I'm either going to cut that back out, or I'll tell you where to skip from this just to save us time and effort. So again, this is what I was just saying verbally, but now I need you to actually see it. What if the doctor asked us for 2 base up in the right, 2 down in the left, but also in the same eye, 2 out in the right, 2 out in the left. There's 2 up and out in the right, 2 down and out in the left. And here's a vertical component. Here's a horizontal component. Here's a vertical component on the left. Here's a horizontal component. So you could have more than one type of prism in the same eye. And this is a very common way: 2 up, 2 down, and then 1 out, 1 out. For the 2 eyes, you split the 2 oftentimes. This is a very reasonable type of prescription here. And then again, I'll repeat this, even though I said it already, I just want you to see it. What happens if the doctor asks for the right eye 3 prism diopters at 45 and 3 prism diopters at 225? This becomes more complicated. This becomes more problematic, if you will. And the reason why this becomes more problematic is we're used to, when we talk about axes, axis on the right, axis on the left, especially as we write sphere of cylinder lenses, as we're doing just about any type of axis, we almost always keep it between 001 or 1 and 180. Well, we don't go below the midline. We don't use axes like 185 or 275 or 315. This is a little foreign to us, but it really shouldn't be, because if you can remember that 365 degrees are in a circle, this sort of makes sense. So let me show method one. We're going to start with the more difficult one first. This is something if we have a specific amount of prism, and the amount and the direction of the base is this second number. So the right eye would have 3 diopters of prism, and it'd be at base is at 45 degrees. The left eye would be 3 prism diopters. The base would be 225. Well, what does that look like in the lensometer? Where would we put it? How do we know is this up and in, up and out? Is it down and in, down and out for each eye? Well, let's show you how it looks. So again, this is that example. What if the doctor asked for 3 diopters at 45 on the right, 3 diopters at 225 on the left, and what they're doing is they're specifying a total amount of prism and the axis and direction of the base. Now, normally it's in, up, out, down, but in this case, it's a little bit of both. There's a vertical and a horizontal, and so you're not going to get at 180 or at 90 or at 0. You're going to get these oblique type of axes. So this is what, if we looked in the lensometer again, I've superimposed some more lines, and you're familiar with the 0, 15, 30, 45 is halfway there, 90 is up and down, 135 is to the left, up and to the left, 180 is here. But remember, if we're always looking at the patient and say this is our lens cross, 0 and 180, 90 up and down, but we're always looking at what's above here. Now we have to start looking at what's below here, because now it comes into play. So now, if we keep going from 180, well, 180 and another 45 degrees is 225. 90 degrees away from 180 is 270. 45 degrees more is 315, and 45 degrees again is 360. Just like there's no 180 and 0, 0 and 180, we now are going to start using, there's no 360 anymore. We just go 0 to 359 essentially. And so 0 is an actual good number. We don't use axis as 0 for eyeglasses for prescriptions because 0 and 180 are the same thing. Well, now 0 and 180 are not the same thing. 0 points to my right, 180 points to my left. So now, if instead you didn't have 3 diopters base up, but you had 3 diopters at 90, that's the same thing. If I'm going straight up, that's 90 degrees. If I'm going to the right, it's 0. If I go to the left, it's 180. But if I went base down, 270 degrees would be base down. So now you can sort of already get this idea. 0, 45, 90, 135, 180, 225, 270, 315. These are all very unusual numbers, but if you understand how a circle works, and we can still do that same going about, it's almost like a lens cross in a way, but we're still dealing with the same orientation. We're just expanding from past 180 all the way back to 0 again. So now let's look at this first one. It makes a difference whether it's the right eye or the left eye. So now remember, in this right eye, we had, here's a prescription, 3 diopters in the right eye at 45. So this is the right eye. 45 degrees for my right eye. Take a look, and it is up and in. So in this case, we would be looking at 3 diopters up and in at 45 degrees. Pretty cool. And that would be a pretty straightforward example. If we instead, and this right here, the other eye, if we did that 3 diopters at 225 in the left eye, let's go ahead and show what that looks like. And it would look like this. So now here's our left eye as we're looking at it, and 225 would be down and in. So if we did this, so you have to be very careful though, because in this case, our 3 diopters at 45, because it's the right eye, is up and in. The 3 diopters for the left eye are down and in. And this would be a very feasible, the horizontal are in opposite directions and the 2 ins are together. So this is going to add in, this is a total of 6 diopters of prism induced at an oblique angle. And this would be straightforward. Again, we have to watch out because if we were talking about that 45, if we're looking at 45 degrees, I won't go to presentation mode, but 45 degrees for the right eye is up and in towards the nose, but 45 degrees for the left eye is up and out. So you really have to be careful. And for me, I don't care how you do it. You can draw it out, you can memorize it, you can, whatever it is, get the pair of glasses and as you're looking at it, look over the top into the lensometer. But this is really, really important. So now let's go into an example of this one. I'm going to ask you, what do we think this is? Again, this is along the 2 diopter lens. So if this is a right eye, you would be able to tell me that this is 2 prism diopters at 45 degrees. If it's a right eye, you know that the effect this has on the patient is 2 diopters at 45 degrees, and that's 2 diopters up and in at 45 degrees. So that's, then if you're checking it out, this is where it should be on the reticle in the lensometer. So if you're dotting up and they ask for 2 diopters at 45 degrees, it should be right here. If, let me get this out of the way. I don't know if this, yeah, I can't cut the X, but again, if we ended up having it here, that's 2 at 90. This is 2 at 135. This is 2 at 180. This is 2 base 225, 2 at base 270. So if I were to ask you in the right eye, if I had 2 diopters at 225 degrees in the right eye, is that up and in, down and out? Up and out, up and in. Well, if I'm looking at 225 in the right eye, you'd have to tell me that that would be down and out for the right eye. So, and I love compound prism. This is pretty cool stuff. So if I go to the next one, if I ask you 315 degrees, if I have a left eye, it would be down and out. If I have a right eye, it would be down and in. So these are sort of important for me for test questions. I'll give you an axis likely, and I'll give you a couple different ideas. Is it up and in, up and out, down and in, down and out? And you should be able to tell me by determining whether it's a right or left eye and just drawing this out or memorizing or what have you. So the second method is, what happens if the doctor didn't give me an amount and a direction, but instead gave me a vertical component and a horizontal component? So for example, in the right eye, the doctor asked for 3 base up and 3 base in the right eye, 3 base down and 3 base in the left eye. And you'd look at this and say, well, isn't that the same thing we just did, up and in, up and out? And the answer is no, 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 no. Because 3 up and 3 in, and I'll show you, they specify this separately. The question is, look at the above. What is the amount? What is the direction? And it's important for you to understand that 3 up separately and 3 in separately and added together, like 2 different vectors, is not the same for the right eye as 3 diopters up and in. If that confuses you, well, let's look at it as if this were a street. If we go down a New York City block and we start at a location and we go exactly 3 blocks over, and then we decide to go 3 and take a look, 1, 2, 3, 3 blocks up. Notice how this is not the same as 3 up and in. It's substantially more than 3 up and in. And that's because this is a triangle. If you have a triangle that is a right triangle that has 1 horizontal component, 1 vertical component, if it's 3 here and 3 here, and it's a right triangle, it can't be 3 here. It has to be significantly longer. This is your side, and then the hypotenuse is the length that is opposite my right angle, if you remember trigonometry. If you haven't, just remember our street signs or our street blocks. So if I ask 3 out and 3 up for a left eye, it's not the same as 3 up and out. It's closer to 4. So when I say closer to 4, the question is exactly how much is it? Well, it looks like about 4 diopters, and it looks like about 45 degrees. So you can look at this, and to make this a little bit easier, I've developed a calculator. Now, ideally, if this were a perfect world, I would actually make you break out a calculator and start doing sines and inverse sines and stuff like that. It's taking too long. And I just am not going to do that to you guys. So instead, I put together a neat little tool for you to play with. So you don't have to break out I already put the formulas in. And this is going to help you out, I hope, for us to take a look. So let me put this over to the side. Let me show you this one. Let me show you this one. So I have a little calculator here, and it's going to help us out and give us the actual amounts. So we went 3 to the right and 3 up. So I've made this little calculator here, and it says step 1, enter the horizontal component of the prism here. That's this right here, this little section here, 0, it could be 1, it can be 2, it can be anything you want. And in this case, we're going 3. And take a look, it says to the right is positive, to the left is negative. Well, this is to my right, so I'm going to put +3. Step 2, enter the vertical component of the prism, and this was 3 up. Up is positive, down is negative. Pretty straightforward. And there we go. So the formula, and it's in your reading, this number squared plus this number squared, add the two together and take the square root. So in this case, 9, square this number, add them two together. So 9 plus 9 is 18. If you take the square root of that, it's 4.2426. Well, we can actually just take this and let's format it so it's a little easier, so that it's only 2 decimal points. So you're looking at about 4.24. And that makes about sense. If you look here, this is not 3 up and out. This is 3 over, 3 up, which happens to be 4.24 prism diopters. And if you look, the result of the axis is 45 degrees. Pretty simple. It makes sense. This is this, if you have going out this way and going out this way, they should absolutely be at 45 degrees. So if I'm looking at a lensometer, I'm going to try to make my horizontal go here, my vertical go here to match up with this 3 and to match up with this 3, and sort of work your way up 3 over and then go up, 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 up until you hit here. And that should be exactly 4.25 at 45 degrees. And this would be up and in, makes sense. If we go 3 down and 3 out, well, this would be for the left eye, 3 down and out for the left eye. So let me do this one. This right here is this right here. So now let's do a brand new one, and let's do a different one altogether. And this is why I put this together for you guys. So what happens if the doctor asks for the red eye 3 up, 3 in, and it's 4 diopters or 4.24 at 45 degrees? That I've just shown you. But now I'm going to show you this. And it looks a little scary, but it's really not. And what I'm going to do here is, this is the right eye, this is the left eye. We're going to start here. And if we're doing prism, you can do 1, 2, 3 over, you can go up, whatever you want. But here you can use these different numbers to start going 1, 2, 3 over, and 1 up. Well, that would be about 20 degrees. And you can do it this way on this little compass or this protractor, if you will. But I wanted to show you this, and let's minimize this and do this. So right now, let's take a look at this example here. Here is my right eye, and we're going to go 3 up. 1, 2, 3 up. But this time it's going to go 3 out. 1, 2, 3 out. So for the right eye, up and out would be into the horizontal component. To the right is positive, to the left is negative. But this time, take a look here. We're going 1, 2, 3 to the left. So this is going to be -3. And we're still going up. I'll fix this in a minute. Let me get rid of this. I'll fix this a little bit because my formula is a little off. I'll have to redo this again. So this is going to give me 3 up, 3 out. Yeah, I must have done the radians wrong. I apologize. So we're just going to get rid of this altogether. And in this case, it would be 135, but it would be 4.25 over here. And so now, if I did 3 down and 3 out, it's still at 4.24. So let's get rid of this direction until I can fix it. And if I fix it, that's fine. If not, still fine. But now let's take a look at this 2 up and 4 out. The horizontal component for the right eye is to the left, -4. And the vertical down, the vertical up is positive 2. And I'm getting 4.47. So if I went 1, 2, 3, 4, and went 1, 2 up, you notice how it's almost on the 4 and change. It's like 4.5. So again, you can put it on the protractor, or you can do a little formula here. So now, again, 4 out and 2 up is not the same as 4 plus 2. It's not 6. It's a trigonometric. It's like a triangle. You walked 4 blocks over and 2 blocks up. You're only about 4.5 blocks away. So we can continue to do these. If I did 4 down and 1 in for the right eye, well, if I went 4 down, 1, 2, 3, 4, and 1 in, only 1 in, take a look, that's actually almost the same as 4. Looks pretty close, and that's what we get. It's like 4.12. So I'm going to get these little axes right. But again, if I ask you to go 4 down, 4 in, you should be able to tell me how much prism I'm looking at and approximately what axis if I use this little protractor. So I'll give you a few examples and maybe we'll work through them. And at this point, we're a little late in the semester to get expert at this, but I wanted to show you. So if I had this one, the right eye would be 4 down, 1 in, left eye would be 4 up and 1 in. So you can start to see where this would be in the either lensometer or the reticle, or we can start getting the angles and the amount. But I wanted to show you how these could work. So what we're going to do is give you a couple formulas, a couple tools. I'll fix this one up a little bit to make sure the axis actually comes out right, because we have to convert from radians to degrees. Don't ask what that means. I'll take care of it. But this is what we're doing. So again, in the whole scheme of things, if you can essentially figure out what the doctor asked or stuff like this, three up and 3 out for the right eye would be 1, 2, 3 up, 1, 2, 3 out, and that would be at 45 degrees. And you can do your math, and 4.24 would be right about there. I would do the math first to find out how far we are, and then I would use this little device to tell me where I am. 4 up and 4 out is exactly at 135. In the left eye, 3 down, 1, 2, 3, and 3 out, 1, 2, 3. Notice that's right along the 315. So let's do 2 up and 4 out. Here's 1, 2 up, 1, 2, 3, 4 out, and that looks like it's around 155 degrees. It's hitting this one right here, so we're pretty close to 155 degrees, and I'd plug it into my little calculator to find out exactly how far that is. 2 down, 1, 2, and 4 out, 1, 2, 3, 4, is around 335 degrees where the base is. So again, You can find out how much it is by doing a squared plus b squared equals c squared and do the math, or just use my little formula. And you can use this here to tell me what the direction is. And then 4 down and 1 in, 1, 2, 3, 4, and 1 in. I would call that around 280, just shy of 285, but 284, 285 I would take. Left eye, 4 up, 1, 2, 3, 4, and 1 in. That's around 105, maybe 104 degrees right there. So this is sort of a little bit to throw at you, but I wanted to make sure you at least could see lightning and hear thunder when it came to compound prism. So if somebody writes you an RX that tells you in the right eye it should be 4 up and 2 in, you should be able to look in the lensometer and get a very good idea of where that is and to make sure that the lab made it. I will tell you that it's one of the more common mistakes that people make when they're making eyeglasses, and they tend to either not understand how to lay it out. The lensometers aren't very good. The auto lensometers, some of these automated equipment, not great when they're doing this. So you as an optician are sort of the gatekeeper to make sure that whatever you ordered, whatever the doctor ordered, and whatever you input is exactly what's in the glasses, especially for these more complex cases. So I'm going to leave it at that, and I'll throw some homework at you just to give you an idea. And generally for my purposes, for quizzes and homeworks for our purposes, oftentimes we're just going to ask you for stuff like, if I give you an axis of say 195 degrees, is that up and in, up and out, down and in, down and out, and that for my purposes, generally for test purposes, will be sufficient. So you understand how that orientation works. So at any event, that's it for me, and I will post this and we'll get you some homework and we'll be good to go. Appreciate your time.